Okay, so let's start. Thanks for everyone who attended. Um, my name is Daniel. If you don't know me yet, I'm the Technical Customer Success Manager of WinDriver. If you are using WinDriver, already used it, we've probably talked before. This is my email. You can contact me regarding any question you have about this webinar, other webinars, or any other subject. Today we're going to talk about how WinDriver helps you to stay ahead of the curve and keeping you updated and aligned with the latest operating system requirements. In these pictures, we see different planes from different eras. I wanted to emphasize that things are evolving. Technology evolves, operating systems evolves, and things are changing. And when we build applications like drivers that heavily relies and dependent on how the kernel is built, um, we need to make sure it is aligned with its current structure. So today we're going to talk about two things mainly. One, how we make sure that your code and driver keeps track with the latest kernel updates, and how can you upgrade your WinDriver version. And it's very, very easy. I believe it won't take too long. So we're going to talk today about WinDriver Advantage, um, the ease of use, and other things WinDriver helps you as a driver developer. We're going to cover WinDriver APIs and libraries, where the magic happens. And then we're talking about best practice and alternative flow for upgrading your driver. So let's talk about WinDriver advantages. We have the kernel compatibility. I will elaborate on each of these. The easy handoff. We have the support and the ease of upgrade when we're talking about the need to upgrade your kernel version or WinDriver version. Um, let's start. So WinDriver is kernel compatible. What does that mean? We know that Linux is an open source operating system, and it has different kernel versions that keeps coming out with different tweaks and flows, and even the most commonly used functions sometimes changes there, and you need to make sure that your driver and the kernel module and kernel plugins corresponds with these requirements and these functions and structs and everything that libraries, everything that Linux is built on top of. This is a screenshot from Elixir website, where you can see the source code of Linux and different versions, and how each function looked in each version. Here in WinDriver, before we release a new version, we go to the kernel version that we want to be compatible with and make sure that our code is aligned with this version's code. So we save you the hassle and worry of keeping track with the Linux latest updates, code updates. And we can say the same about Windows. We all know that Windows 10 is going to be obsolete in October, which is going to be a headache for a lot of people who develops drivers for Windows. They need to migrate, and it's not just install the driver you developed on Windows 10 and Windows 11. You need to be compatible. We know, I can tell you now that we saw that Microsoft added an enforcement on the digital signature. So the digital signature is a bit different. Linux, we now have an update which we will send in the next days regarding the option to lock contiguous DMA buffers. You cannot lock them during runtime. You will need to pre-allocate them. We will send a message regarding it. But if you're using the latest Linux kernel versions and trying to lock contiguous DMA buffer, you will get a BSOD. So again, things are moving, things are changing. With WinDriver, we do our best to answer these challenges and the requirements. So it's not just being compatible with every version and kernel build requirement, but also being cross-platform. So if you don't know this yet, developing a driver with WinDriver, you can build it. You develop it in one environment, and you have a build file which you can build your driver on Linux, Windows, CentOS, macOS, etc. So we're not only keeping updated and keeping track with the latest specific versions requirements, but it is also cross-platform. You can distribute your driver and build it on different platforms. So if you are planning to distribute your driver on cross-platform, you don't need to build a new driver or make the necessary modifications. You can simply build it with the make files we provide and automatically generated with WinDriver. So this is another great capability we offer for teams and driver developers. Another, you can say, hot topic is ARM. So ARM has different architecture. It's the same when you compile on, there's a difference between compiling on 32-bit and 64-bit. So here as well, you need to have your libraries with the compilation flags that are compatible with ARM requirement. Otherwise, it will not work. So we did a job for you. We have on the lib folder of WinDriver the necessary files and configurations to allow you to not worry about it. You can develop on Windows or Linux, and you have ARM compilation library automatically generated. So it is compatible with ARM architecture and processors as well. Now, this is feedback we received from clients regarding a major advantage of WinDriver. So we know that usually when we talk about hardware, there are many, it's even different teams or different divisions. There's the hardware and the design. And we have the kernel developer sometimes and the software developer. And there's a handoff between teams. And you go back to the design and with the requirements and it returns. And as more people are involved in the process, the communication can get rough. What we offer in order to make it easier for teams to develop the driver is not to be dependent on their staff logic or the way they see the code. We have a documentation, and I will talk about the functions in the next slide. But we have a very elaborate documentation. We have the support, which if you develop by yourself and not with WinDriver, you don't have. And we have a lot of content. We have videos, webinars like this one. We have blogs. And we have a lot of content which can help you going through the development process successfully. So the easy handoff, we make the handoff between teams easier by providing a support documentation and content, and also the code itself. The code has coherent functions name. It not depends on one person's logic, and then during the handoff, someone else decided that the functions name are not as they should. So we have coherent functions name. Let's say device open, the driver name is Salmon, device open, it opens the device find and open, finds and opens the device. and I will talk about these functions soon. What does it mean, the WDC? And we have a wide in-code documentation. So it's not only the documentation on our website, but also in code. You have all the parameters, the signature breakdown, which parameter it takes, what's the return value, and so on. So it really makes the development easier, both for the developer and the team, which will join later or work in parallel to him. When we talk about support, so this webinar is about how to upgrade your WinDriver version in order to stay compatible with builds and kernel versions. We offer, and this is the first time we talk about it, a free version upgrade session for past clients. So if you used WinDriver in the past, version 6, 8, 10, 12, and you want to upgrade to the latest WinDriver 16.4, we can have a session which we will guide you on what to do. Again, it should not take long anyway. It can take a few hours tops, and you are good, like for the latest version. So if you're interested, send me a message, send us a message via the website, and we will help you upgrade your WinDriver version. We have fast SLAs and high responsiveness. I think our clients can tell. New features. So in each WinDriver version, we provide new features. For example, the latest version came with Lattice XDMA, not XDMA, sorry, Lattice DMA IP samples, compatible with two Lattice devices, the Avant and the Certus Pro NX. In the version before that, 16.3, we added the predefined actions feature, which you can create a flow of actions and running them on your device. And so on. So we have on our website, we have the release notes of past versions, and you can have a look. And another thing, which when we talk about Windows 10 being obsolete, it's the security thing. I understood that one of the main reasons Microsoft's drop support of Windows 10 is that it is not as secured as they think it should be. So we provide enhanced security with each version. Again, things are moving, things are changing, and we keep adding security measures to WinDriver. So the latest version you're using, the safer it gets. Now, this is something, this slide is for really past clients that they want to upgrade. We get a lot of time, we have like a resistance of why not to upgrade the driver. It's like climbing a wall, okay? Because it is an untouched legacy code written in the early 2000s. No one has touched it and no one wants to touch it. It may be the foundation to other complicated components. It takes a lot of time, a lot of effort. And basically, we hear a lot, if it ain't broke, don't fix it. We're using WinDriver 11.3. We don't want to upgrade to the latest version because our version works with our current configuration. So why should you upgrade? And here it's like an elevator. It's not that hard. So we know the things breaks. Okay, fix it before it breaks. We know that we saw the kernel, especially in Linux, the kernel keeps changing. Operating systems are becoming obsolete, out of support, etc. So stay ahead, fix it before it breaks, because when it breaks, then that's where the stress comes into play. So keep updating your drivers. We have a lot of clients that does that. So we again recommend staying ahead of the curve. The high-level API, which I will talk about soon, has less code in it, up to 50%. Older versions of WinDriver used low-level API, which required much more code, hence much more complication. With the high-level API, you have up to 50% less code and a lot more efficient functions and operation. So it's more efficient. You have better performance because the code is more efficient. We don't support older versions of WinDriver. If you have a bug in, again, WinDriver 10.3, we won't fix it because we've probably fixed it along the way. So support is a big thing. And we keep saying that to clients that comes with old versions of WinDriver, even for the sake of support, use the latest version. And the last reason, which I will talk about now, is that it is very, very, very easy to upgrade. It's not that complicated as one may think. You can isolate your environment and put it on a test environment and give it a few hours. It shouldn't take longer than that. And eventually, you will get a much faster, more secure, and better driver and platform, WinDriver. So let's talk about WinDriver's APIs and libraries. This is like a deep dive for how we manage to track and stay ahead when talking about upgrading. If you don't know WinDriver, so this is how WinDriver work. We provide a user mode application and code for you to write your kernel mode functions and driver. So we provide the kernel module, WinDriver's kernel module. It has its API, low-level API, and we have the high-level API, okay, the WinDriver API, which calls the low-level API in order to perform operations in the kernel. As I said, the high-level API is only a few years old, but it is much more. The best practice is to use the high-level API. Okay, it is calling the low-level API, but it is more efficient and easier to use. So your driver or your application, user mode application, contains WinDriver API that communicates with the kernel module. If you're using Windows, you also need the INFs. I won't get into it right now. What I do want to say is that everything here is automatically generated. So if you haven't worked with WinDriver, this is what your project will look like. This is something we've added recently, a comparison table for the low-level API and the high-level API. There are some example here, as you can see, that a few one high-level API replaces a few low-level APIs, and I will talk about this example soon. High-level API, you can recognize it by the WDC, WDU, or WDS. C is for PCI, U is for USB, and S is for server. The low-level API starts with WD. Okay? And again, the high-level API calls the low-level API, but it is more efficient. It's built better. So let's see an example. Here we have the opening routine example. If you want to open your driver with a high-level API, you use the WDC driver open. It already does the all license verification, opens the device, and so on. I think I have, sorry. You need only this function in order to open your driver. If you're using a low-level API, you need all of this. Okay, the WD open, you need to reset the memory, to copy the license in order to verify it, much more code. So this is one example, and again with the driver close. Although it's a shorter routine, it is less efficient. So this is one example for using high-level API and how it can save you complexity of the code. The WD enable, WDC interrupt enable, I will not get too deep into it. We have an entire webinar about interrupt handler, but this function does a lot of things. Okay, it opens a handle, transfer to the transfer commands, to the callbacks. It listens to interrupts. It waits for interrupts. Basically, doing this. Okay, all of this routine and more is being stored or contained in this high-level API. So this is just another example of how using the high-level API can save you time and complexity. It is easier. Now, when we talk about differences about key differences across WinDriver versions, we need to break down the components. Everything, again, this is a deep dive. You don't need to know this if you're using WinDriver because it's transparent. Everything happens in the background. This is the thing with the ease of use of WinDriver. If you will upgrade your driver using our best practice, you don't need to know any of this. However, if you want to know how it works, or if you want to do it manually, then you should really know which components are changing and different across versions. So you have the project source file, okay, which is the generated project. It's the project folder in the WinDriver folder. You have the API source file. We will go through each of these soon. The API source files in the source folder of WinDriver. The header files are stored in the include folder. The static header files are the dynamic libraries. The static libraries are in the lib folder, and the resource file for Visual Studio and Windows are in the resource compiler. If you open the project using VS, you should see the RC file there. Licenses up to 16.3. You need a new license for each version. If you have a valid subscription, we will generate it for you for free, okay? But it needs to be compatible with the version. From 16.4, if you are using an online license, you don't need to change the string, but you need to let us know if you've changed it, okay? Like 16.4 is the latest version. In 16.5, you should tell us change the license to be compatible to 16.5 as well, so you don't have to change the string. But until up to 16.3, you have to change the license and ask for one on every WinDriver version. INFs, needless to say, this is what will allow you to install your driver on Windows, and it needs to be version specific. So in any case, if you're upgrading a version, you need to generate INFs from this specific version. Dependencies. So as I said, things are changing, and this is mostly for Linux, but also Windows and Visual Studio. Things are adding up, things are changing, and you may need to install new dependencies that were not required in the old version. Okay, everything is listed on our documentation, but it is important. Do not follow all the version steps with the new version, a new environment when you upgrade. Go to the latest documentation and see what it says there, because this is the whole idea. Some things we control, the behavior of the driver, and how it communicates with the kernel and the operating system. Dependencies is something that you need to do before, to install before using WinDriver. And the kernel module. Of course, the kernel module includes the relevant low-level functions, and it needs to be the latest kernel module of the driver of the version you want to upgrade to. Okay, now everything I'm showing here exists on your computer if you installed WinDriver in both Windows and Linux. Okay. Why is it important? During the upgrade process, especially if it's a very old version, you will get errors. Okay, and we'll talk about the errors. The function is not set right. The parameters you entered are not valid. The paths are not linked right. And all of these are occurring because the difference between the WinDriver version, the latest, or let's say this specific version functions are described here. Okay, so if you want to deep dives and see which low-level function the high-level API calls, this is the place to go. If you want to add, you can add them here. So again, some functions and APIs have changed in the course of the years. Make sure your WD API functions calls are correctly formulated. So if you called, and I will talk about it, if you used, let's say, 4 parameters in the old version and the new high-level API requires 5 parameters, it won't compile, it won't build. You can troubleshoot it via VS, but this is another place you can see what the functions are formed from. Okay, so WinDriver H is a huge file, a very important one. All of these are already included in the WinDriver H file. And if you want to include any other header file that provides APIs, you can add it here. Okay, this is all the includes. I will show you. We will talk about links, and this is very important. Okay, so make sure that the WinDriver.h, the header file, is set right, the path, and and sorry, and that you have everything you need in order to make the driver work. If you are using or doing it with our best practice, you don't need to worry about it. This is only for the manual. The static libraries are set in lib, in the lib folder. And again, if you want any other source file to implement to your API, add them here. Now, what do I mean by that? Or again, I said here, if you want to include any other files. WinDriver provides a code, which some of it you are adding the parameters. Let's say the offsets, right? The functions, reading and writing, and you're doing you're setting the driver to do whatever you want. Sometimes, and especially in the old versions where we had a low-level API and we didn't have the convenient features we have today, you had to manually create more code and more libraries, okay? And you needed them to be included in your code. It was much more complicated. And I'm talking about WinDriver again, 6, 10, many years ago. So if you generate the project now, you will have everything the driver needs to work, and everything you set up in the driver wizard. If you have components that you've added, again, in the old version, you need to make sure to include them to the new generated files. So let's talk about best practice and alternative flows for how to upgrade WinDriver. So this is the regular flow, the regular routine. You generate the code in the wizard. We recommend using the makefile because it includes all the compilation flags and everything for every other environment. And then gradually merge the code. Okay, so you have the generated code. of the latest version, and you have the old code, and then you start migrating your old code to the new driver. Now, what's the catch here is to do it gradually, step by step, okay? Because it makes the debugging easier, and it will help you to keep track of changes. So the generated code will work for you because it works, and then start adding things. And if something breaks, you will know exactly what happened. Now, when you do this, when you work like that, when you generate a code in the wizard, all of these components are already set. Okay, they are automatically generated or installed. They are already there. Okay, maybe except for the license and dependencies. But all of these files, all the critical components for WinDriver to work, are already generated and installed when you work like that. So everything I just said is transparent to you. All you need to do is to move your code and to make sure it corresponds with the latest functions. There is another way to do it. Now, why would someone choose not to do it like that? Because it's scary. People are afraid to download new versions of things, and it's understood, right? We don't like it when things breaks, but it will require more work. Not much more work, but more work. So this is, let's say, the best practice, the automated routine or flow. What happened, or how can you manually upgrade your WinDriver version? It's 5 steps. The last one is to run. So we will go through the first 4 thoroughly. You open the project in the new environment. It's pretty straightforward. You need to set the paths right. Make sure that all the includes are recognized. Commit to API changes. Set the compiler definitions and run and distribute. Let's see how it is done. Okay, so we have the old environment. For here, for example, we developed the PCI diag from WinDriver version 12.5.1. And now something broke. We needed to upgrade the operating system, or the computer, I don't know, burned, and we have a new environment. And then you say, okay, so if we're moving to a new environment, let's try to catch up with the latest updates. But I don't want to install WinDriver. I want to take this code and start manually adapt it to the latest WinDriver requirements. So what you should have in the new, from what should you take from the old environment to the new environment? Basically, your project folder, the code files, CN headers, the sys file, and the project configuration files or make file, okay, that are compatible with the target IDE. I will talk about it, because when you're moving environments, it's not only WinDriver that changes, many things can change. Here, it can be Visual Studio 2017. Here, it can be Visual Studio 2022. Or even when we talk about Linux, the GCC version, or any other dependency that is required in order to make WinDriver work and your driver work. Also, make sure that you have a valid license, not only for the WinDriver version, but also for the architecture that you are using, OS or CPU compatibility, the operating system, the architecture. If you're changing the VPID, we need to know about it. From 16.4, you won't need to change the license string. Prior to that, we need to generate a new license for you. Okay. So as I said, you need to upgrade the project environment if needed. Install Visual Studio, or again, whatever compiler and IDE you are working with on Linux, if it's GCC, if it's Visual Studio, VS Code, etc. We recommend moving to CMake. CMake is a file that contains the relevant flags for building on cross-platform and architectures and and other moving parts. If you don't know it, send me an email or watch a previous webinar or go to our documentation. It's a great tool. Always compare with the project from the current version. What does that mean? So you generate the code. Sorry, you don't generate the code. You move the project from the old environment to the new environment. Things are changing, as I said, and maybe the flow has changed, maybe the function name has changed. A lot of things can change. On the new versions, on each new version, we have a sample. These samples are working, okay? We develop them to serve as a skeletal code. Not just, but also as a skeletal code. They are great for debugging because, again, they are working. So whenever you are migrating to a new environment with WinDriver, go to the sample folder and see how we formed the code there and what have changed from your version to the latest version, diff it, and it may solve a lot of misunderstandings and time. Okay, ensure that the platform toolset configurations is correct, and validate compilation language standard is correct. If you're using a C++ in addition to C, talk to us. I won't now get into manglings and other definitions, but we can help you with that as well. If you have both C++ and C code in your driver and you want to upgrade your version, talk to us and we can help you do that. So after we moved all the relevant files and we saw that the operating system is ready for us to build our code, program. We're not building yet. Then we need to set the paths and links right. So we have the project configuration file, and you can see that you have the place here to set the path for the includes. In some versions, the paths has changed significantly. So I recommend go to our documentation, find your version, and see if there were significant changes in the paths. Because in the recent WinDriver versions, there was no significant changes in the, let's say, folder's name and where they are located. But if you're using a very old version, go to our website and make sure that the location you are running the project from is set right to the latest version files and includes. So the red line under the include will vanish, and you will have access for the dynamic libraries where all the high-level functions are, high-level and low-level. Now, I'm sure you know it, but this whole process requires building and failing, building and failing, building and failing. Use these fails or these logs in order to find what's the next step. Okay, so C code can point out for missing includes file, or it's not finding the directory, meaning maybe, the path is not set right. Linking error, again, for unfound libraries. Link error 2019 for unresolved external symbol. All points out to bad linkage. Your code, you just migrated to the new environment, cannot link to the latest version files. So this is a very important step to make sure that the paths are set correctly. Now, there's one thing to find the files that include the functions, and that's another thing to use these functions properly. Okay, so some functions have changed between WinDriver versions, the numbers of parameters entered, the return value type, and so on. Review the logged errors and apply necessary fixes. Okay, so here we have E-type error. If you see these, just go to the function and see what it requires, what parameters you need to submit there. And if things are not clear, go to the folder. Okay, the API folder, sorry, the dynamic library, and see which function calls which, does what operation and calls which low-level function. So you can communicate it and make it work. Again, all of these are due to APIs that were changed during WinDriver versions. It may be frustrating. However, again, from the versions I upgraded 12.5.1, it doesn't take too many API conforming. So if you see this error, things are not compiling, and you get an E error, it is probably related to a specific function and the way it is being called or utilized. Okay, the last step, after we got the driver working and all the functions are set right and it is doing whatever we wanted it to do, we need to set the preprocessor definitions and compilation flags. Now, there is one, if you are porting from 32-bit to 64-bit, okay, you need to have a specific compilation flag. We have it described and elaborated on our website. Struct sizes are critical, okay, because we're talking about different architectures. And make sure to add the preprocessor definition and compilation flags. Now, you can do it in two different places. You can do it in the project configuration file, okay, or you can do it in the project settings, okay. And this screenshot is from some Visual Studio. It's not just being to avoid conflicts, okay, but also to avoid duplicates. Because if you have the same compilation flag here and also here in two different places, it won't build, okay? Because it takes order from one source only. So make sure there are no conflicts and duplications, and that again, everything is set right to your new environment according to the version you are using. And the last one is to run and distribute. Okay, so this whole process should take no more than a few hours. And this is like tops, a few hours. Isolate, create a new environment, a test one, might give it like a day, and you can talk to us to guide you through it. By upgrading, you're getting a better and more secure and compatible drivers. And again, we offer a free upgrading session for past clients. So feel free to contact us, and you will have time for coffee after getting it done fairly quick. Short recap. If you are doing it with our best practice, 3 steps: generate a new project, gradually merge your code to it, run and distribute. If you're doing it manually, you need to open the project in the new environment, set the paths right, commit to API changes, modify the compilation flags and definitions, and run and distribute. And I want to thank everyone who attended and stayed. This is my email. Feel free to send me emails. This is our sales email. And you can also ask questions on chat. I'll be here in the next few moments. You can ask me questions here on Zoom chat. Thanks.